Okay, so like I said, we're going to go on and do, one of our goals is to be able to approximate trig ratios and find their angle values using our calculator. And we're also going to talk about some identities called the Pythagorean identities and the double angle identities. You might have looked at those a little bit last year. Okay, finding trig ratios on the calculator. We did this on our last quiz, but I just want to review. Those three you'll go back and do. Let me just do a little example down here. The cosecant of 3 pi over 7. First of all, we look at our calculator, and we do not have a cosecant button. So we're going to have to type this in as a sine. So we're going to have to do 1 divided by the sine of 3 pi over 7. Because cosecant is the reciprocal of sine. What else do I have to check? The mode. We have to be in radians. We're going to put that in radians. And we're going to do 1 divided by the sine of 3 pi over 7. And there is our ratio, 1.0257. We're always going to go out 4 decimal places past. Okay, so you'll go back and do those others. Okay, this is what I just showed you in the warm-ups, but I'm now going to do a harder problem than the ones we did in the warm-ups. This is what we're going to do over here to the side. Same directions, but we're going to do cotangent theta equals negative 1.4172. Cotangent theta equals negative 1.4172. All right, look at the directions. Find the angle values in degrees to the nearest degree from 0 to 360, including 0, not including 360. We have a cotangent problem. What do I have to turn this into to be able to do it? Tangent. So to change it into tangent, we have to flip this over. So it's 1 divided by negative 1.4172. I'm looking for an angle, not a ratio, but an angle. What do we have to push when we're looking for the angle? Okay, well, yep, first I'm going to change into degrees. That's one thing. But also, if I'm looking for an angle, I don't type in tangent of this. What do we push? Second tan, or tan to the negative 1, inverse. So second tan of 1 divided by negative 1.4172. Push enter. All right. What's the problem with this? It's not between 0 and 360, is it? So I need another name for this. And we're going to go out to the nearest tenth. It says to the nearest degree, but we're going to go nearest tenth. So here's what we've got then. We've got this angle of negative 35.2. Negative just means it's going in this direction. I just can leave off the negative. That's just telling us direction. 35.2 is that angle. Fatima, how can I find the angle instead of going this way, the one that goes that way? What can I do? Okay, so I can take this negative angle and I can just say plus 360. That will work. So 324.8 is going to be one of my answers. Okay, now I've got to think there's probably 2 answers. Cotangent and tangent are negative. In which other quadrant besides quadrant 4? Quadrant 2, good. So I go to quadrant 2 and now find that answer. I know it's still 35.2 for the reference. Grace, what did you get? Yeah, Grace, type it.
145.
Did we all get that? Yes, that is correct. Okay, so that's the way that we do those types. Some of those will be easy, some a little more challenging. Okay, go down to the next part. Find the angle values in radians for theta to the nearest hundredth. Now we're in radians, and we have to be in between 0 and 2 pi. All right, all we're doing here is sine, cosine, and tangent. We're not going to do the reciprocals. So let me just give you a tangent problem here. Let's do tan theta equals negative 2.4161. Okay, Brendan, do you know the difference in the process here? What I'm going to have to do first?
You're going to have to make sure that you're in radians.
Okay, so we're going to go to radians. Good.
And
Then what?
the second thing,
Second tan. Good.
plug in the number.
Plug in the number. Okay, we get this. All right, now what the heck does that mean? We got theta is about negative 1.18. All right, so looking at that, is that in between 0 and 2 pi? What we're really looking at is something in between 0 and 6.28. That is not positive, so it can't be in between those two. So I'm going to have to draw a picture, and instead of going positive, this is negative angle, 1.18. It's that angle. See if you can find the angle that would go this way. What's the angle that would go in that direction, the positive direction? Jordan, do you have it? Not sure. Alyssa? Say it again. Okay, let's see. So we do negative 1.18 plus 6.28, right? That's going to get us, because we have to go around two revolutions, and that's going to give us 5.1. Good. Now, which other quadrant's going to have the tangent negative? We just did this a minute ago. Which one was it? Grace, let's go with you this time.
So that would be 2.
Quadrant 2, good. So 1.18 here still, but now we're in quadrant 2. Do you know how to find that in quadrant 2? How do we find that? Matt, how do we find it?
3.14
Minus 1.18.
or 1.8, sorry.
That's okay. That's right. 1.96. Good job. Okay, everybody got that now? All right, very good. Okay, unit circle and Pythagorean identities. Here's how this works. We've got our unit circle. If I draw a picture of this, right here, this would be an X. This would be a Y. This would be a 1 in the unit circle. This is a right triangle, so therefore x squared plus y squared would have to equal 1 based on the Pythagorean formula. Now, what's another name for x in the unit circle? If this is theta, cosine, right? So if this is theta, then I know x, another name for it is cosine theta. So cosine theta is another name for x. Cosine squared theta plus, what's another name for y? Sine theta, it's getting squared, must equal 1. So based off of this, we know that identity. But there are two others. So watch what I can do. Any equation can be divided. So I'm going to divide this equation by x squared. This one that we know. X squared over x squared is 1. Y over x is, what's another name for y over x? Not sine, tangent. So that's going to be plus tangent squared equals, and what's 1 over x? The reciprocal of cosine is secant, so equals secant squared. That's another one of our identities we're going to use. Does that make sense now, where they came from? Okay, what else can we divide by instead of x squared? Let's divide by y squared. So what's x over y? It's a little tougher. Cotangent. So that's going to be cotangent squared. Y squared over y squared is 1. And what's 1 over y? The reciprocal of sine is cosecant. You do not have to memorize those. Okay? You can figure them out on your own. I never memorize something that I can just figure out. All right, let's go to the back. All right, so I'm going to do a couple down here, just this little space. Actually, let's go down to the very bottom where we have a little more room. Going down to the very bottom, I'm going to show you some examples of how we're going to use this. So let's say we have cosine x, sine squared x, minus cosine x that we're supposed to simplify. Well, looking at this problem, this is a term, and this is a term. What do those two terms have in common? So I'm going to factor out a cosine. And then this divided by cosine is sine squared, minus cosine divided by cosine is 1. I'm trying to get this simplified down to a single value. So I've got cosine x. I need to know what would sine squared minus 1 be the same as? Be careful, is it cosine squared? It'd be negative cosine squared, wouldn't it? So I can replace sine squared minus 1 with negative cosine squared x. So what's cosine times cosine squared? Cosine to the third power. So this can all be simplified to negative cosine to the third. All right, let's do one more. What about this? What if we have cosine to the third x minus cosine squared x minus cosine x plus 1? Would you know what to do here? How you can factor when you have 1, 2, 3, 4 terms? Grouping, great. So we're going to group these two and these two. What can we factor out of these two? Cosine squared x. I'm left with a cosine x minus 1. Now, I have to factor out the negative 1 here. So I'm going to have a cosine x positive divided by negative is a minus 1 again. So now I've got this term here and this term here. What do those have in common as a factor? All right, so I can factor out cosine x minus 1. And when I take it out of this one, I'm left with a cosine squared x. Take it out of here, I'm left with a minus 1. So now I have to think, is there another name for cosine squared x minus 1? Would it just be sine squared, or is it the negative sine squared? It'd be negative, wouldn't it? So I can simplify this a little more down into cosine x minus 1 times negative sine squared x. That's a little tougher. And there's nothing else I can do with this. I'd like to get it down even more if we could, but we can't. So we just got to leave it. All right, did you guys do double angle formulas last year? Do you remember? Some people say no. Okay, double angle formulas. It says this. If I've got 2 sine u sine of 2u, or I'm sorry, if I have 2 sine u cosine u, that's the same as the sine of twice the angle. Look at the pattern. The 2 goes down to a 1, the u gets doubled. See, look, if I wanted to do this problem, this is a bit of a pain. You don't need to do this, just watch. I'd have to go in, make sure I'm in degrees. Oh, you know what, I don't even need a calculator for this. I can do 6 times, the sine of 30 is 1/2. The cosine of 30 is radical 3 over 2. So that's going to give me 6 radical 3 over 4. So what would that be? 3 radical 3 over 2? Yeah. So it goes down to that. I can do that problem, but watch how much easier it is if I simplify it first. So what's my 6 going to go down to based on this pattern? 3. And then I'm going to have the sine of, and then what do I do to my angle? Double it, so now it's 60 degrees. Now watch how easy this is. It's going to be 3 times the sine of 60 is radical 3 over 2. My answer is 3 radical 3 over 2. See how that makes it easier to work with? So on this pattern, we go from 2 to 1, and our angle gets doubled. On this one, cosine squared minus sine squared, there's no coefficient that changes, but then we go to just the cosine of double the angle. Look at that pattern. So what's this going to go to? Cosine of 80. Wouldn't you much rather type that into your calculator than having to type in all of that? In calculus, we do a bunch of work with derivatives, integrals. We get an answer like this that we have to evaluate. Too difficult. But if we know that pattern, all we have to do is type that in. Okay? Let me have you guys just do 2 down here just to check you've got it. Let's have you do number 1 and 3 on your own or with a partner. Check with your partner, and I'm going to call on some people.
Oh, yeah, that's
All right, Morgan, what did you get for number 1?
5 sine 2x.
Everybody agree? Yep, she's right. And what about number 3? Tora, what'd you get on that one?
2 cosine 6x.
That's correct too. Did you guys get that? The reason there's a 2 is because really you have to factor that 2 out first of both of those, because you have to get it into that form where there's no coefficient. So now there's no coefficient in front of this, so we just bring down the 2 and then we look at the pattern on that. So you'll finish that. All right, a little bit more, almost there. I want you to look at this. This is our unit circle again. Right here at 0, what's the point, everybody? What's that point?
1, 0.
Next point? Next one? This one? Okay, so what's the pattern then? At 0, what's the sign at 0? 0. At pi over 2? At pi? 3 pi over 2? 2 pi. Okay, so this pattern goes 0, 1, 0, -1, 0. It does that forever. Back here, -1. We could continue it. Remember doing this last year? All right, so there's the sine. What about the pattern for cosine? Well, that's starting at 0 for our angle, then pi over 2, pi. What is it? What's the cosine right there? Next one? Next one? Keep going. And? Okay, so here we go. 1, 0, -1, 0, 1, continues forever. It's called a periodic function. Okay. Just real quick, tell me about this. What is different about this from this? What's the difference between this and the one we just did? Yes, what is it, McKenna? Amplitude of 2. So that makes it go twice as high, right? Okay, what about on this one? What's the change? Do you remember what happens if we have a 2 in front of the x? Go ahead, McKenna.
Is it like where it goes through the x's change?
It does. Because what this is going to be is it's going to be a horizontal shrink by a half. Remember how it's the opposite when it's with the x's? It's the opposite of what you would think. You would almost think the x's get doubled, but the x's get halved. So what happens then is we're going to hit all these key points, not between 0 and 2 pi, but in between 0 and what? Pi. Okay? Twice as quickly do we get through the points. So really this changes what's called the period. The period is now going to be pi. Up here the period was 2 pi. But down here the period is just going to be pi. What does this do, guys? This is a shift to the left. Good. Left pi over 2. What's this going to do? Up 2. Great. Okay, this just goes over all of that again. We're not going to go through it. I feel like you guys know it. Okay, we're going to jump to the hardest one because I feel like you guys have this so well. We're going to do this really, really complicated one. So exciting. All right, so normally, I always like to write down what our normal key points are to start. So I look here. I say, okay, I've got cosine. That's 0, pi over 2, pi, 3 pi over 2, 2 pi. For cosine, do you remember what the points were normally? 1, 0, negative 1, 0, 1. Good. Okay, so we took care of that. We know what that does. The next thing we're going to look at, though, is do we have a change, a horizontal stretch or shrink? Yeah, so what's going to happen? Everything's going to get a horizontal what? Is it a shrink by a half or a stretch of 2? That's going to be a stretch of 2. So that's now going to make all of these x's get doubled because it's a horizontal stretch of 2. I always like to take care of that next. So basically I do this first, this second. Now I'm going to look at this because these are all affecting my x's here. What does this do to my x's? Shifts them what? Left pi over 2. Once I see the pattern develop, then I don't really have to think. You see what I did? I subtracted pi over 2. I subtracted pi over 2. I saw the pattern, negative 1, 1, 3, 5, 7. I didn't have to think anymore about it. Now, what does this negative 2 do to our graph? All of the y values, right? This is a multiplier for the y's. So all these y's get multiplied by negative 2. So I took care of that. Fourth. And then lastly, this. What does that do to everything? Down 3. And now we can graph it. Negative pi over 2, we're at negative 5. 1, 2, 3, 4, 5. Pi over 2, we're at negative 3. At 3 pi over 2, we're at negative 1. There we go. Now, when I was in college calculus, I always wanted to be able to check things. This is something I think you guys may not have seen last year, and it's a really great thing to do. I want you to go to y equals. Clear out anything you've got. We're not just going to look at this graph. We're going to check the table. I'm going to show you how to do that. So type this in. Negative 2 cosine 1/2 parentheses x plus pi over 2 parentheses parentheses minus 3. We're going to type this whole thing in. It will. We want to be in radians. I'm going to double check my mode. And it's a good thing we did. Thank you for that reminder. All right. So now what I want to do is I want to just check my table of values. It seems hard to do this, but it's not. If I look at my table right now in blue, if I go to that table, I'm seeing all kinds of random stuff. That's not what I want to see. I have to set up my table. Did you guys do this last year? Set up your table? Go to second window, and where's this table starting? Negative pi over 2. Delta table. That means how much are we adding every time to these x's in our table? How much are we going up by every time? Pi. So I'm going to go up by pi. And now when I look back at my table, look at this. -5, -3, -1, -3. See how I can check it now? And I know that I did that right. These are the correct points. I think that's even better than just looking at the graph. Because looking at this graph, I can't really tell if my points are exactly right. But by looking at that table, I can tell if those points are exactly right. Okay? All right. One more. This one right here. Tough problem. Here's what's happening. We have to work backwards. So I'm given the points 0, 3, 1, 1. And we have to come up with some sine curve that would go through those points. Some sine curve that would go through those points. Well, let's think about it. It can be a sine curve or a cosine curve. Let's look at the pattern let's go back and look at some patterns here. For sine, what do you notice about the first, third, and the fifth? They're the same. For cosine, what's the same? The second and the fourth one are the same for cosine. So look at the pattern here. Which is it, sine or cosine? Cosine. These are the same. This is a cosine graph. I know that much. It's y equals cosine. That's all I know for now is it's cosine. Oops, I circled the wrong one. Darn it. That one. Do we know anything else? Is there anything else you can tell me that happened to the graph? Up 2? Is that what you said? All right. Well, let's see. In the cosine graph, these are supposed to be zeros. That's what we have to look at to see if it went up or down. So what did it actually do? It didn't. What do you think, Fatima? It went up 1, actually. So it went up 1. So we have to take that into consideration. Anything else you know? Go ahead, Alex. Okay, so that amplitude is 2 because we have a vertical stretch. See this vertical stretch? It was supposed to only be 1 there, but it's 2, so we have an amplitude of 2. What about shifts? Did we shift left or right, or are we just starting where we should start? That's fine, isn't it? All right, now we have to figure out one more thing. This is supposed to go from 0 to 2 pi. And that happens when there's a 1 in front of the angle. This is going from 0 to 4, though. That's telling me that the period equals 4. Do you know the formula to find the period? 2 pi over b. So I know the period is always going to be 2 pi over b. I want to know what is this b value. So what are we going to do? What do we plug in for the period? 4. So I have 4 equals 2 pi over b. Go ahead and solve that. 4b is 2 pi. So what's b going to be? Which is pi over 2. Pi over 2. All right, so here's what we know. Amplitude, 2. That goes there. No change. Well, actually, I do need something. I need in front of this x, I need my b value. So I need a pi over 2 in front of that x. Squeeze that in there. And then how do I make it go up 1? Just put plus 1. Now, you don't have to follow along here, but let me show you how nice this is. I put in my 2 cosine pi over 2 x plus 1. Now, if I go and look at my table right now, I should see those points, but I don't. Why don't I see those points? What did I not do? Set up the table. I got to set it up. Where's this table starting? What's my first x? 0. How much am I going up by? 1. Now look back at the table. If this is the correct function, I should see those points. And I do. So I know that I got that equation correct. Okay? All you guys have to do is go through and finish up the notes. T5 and T6. Yep. It's not that many. It's only like 10 or 12 problems. T5, T6 only. We're not doing a worksheet. We're just we do, but we don't need it yet. Everybody's tired, getting used to getting up early and everything.
I feel like 5:30 every day. But I think the first building is 7.
Are you doing the choir leadership thing? Wake up a list. Are you all sick as well?
No. Early.
No.
Yes. And you don't get out like
The only good thing about early ladies, you don't have to fire everybody.
But you know, sometimes I think in the morning, I would be here, and then I would just blink and then like, now that I'm
So it'd be like 10:30.
don't know how today. But on Thursday,
I'm gonna go far away.
Yeah, you
Man, I can wake up.
I should get like 3 hours of sleep.
Yes, ma'am.
My mom doesn't know.
I wake up. Yeah, I wake up. I have like 7 alarms. I wake up at like 7:30. 8 o'clock. I won't wake up till the first one. It's always so the last alarm
Ben knows, bro. Ben kind of knows everything. I don't know why.
See ya. Have a good day. Thank you. You too. How's it going, Alex? Good. How's your friend Colin doing?
I'm doing pretty good.
I saw him the other day in Mr. Meyer's room. So, yeah.
Wait, do you read the quizzes?
I have not. I've got to
Okay,
do that
so
today.
if you want to go ahead and grade mine, but so for units, so you know how you go like over radical 2 up 1 over 2, and then over 1 over 2 up radical 2 over 2.
Yeah.
So like,
Did you do the opposite?
yeah, and I've had it like memorized since algebra 2, so I like, and like literally on my notes, like everything is fine. I turned it in, and I looked at my notes, and like, there's no way, like I just did that. Like there might be a chance I still did it, but like, if that's the case, that's for sure like a 0. But like, I
It
swear,
won't be a 0.
it will, because like it will be everything for the tangent, because I remember in my head, because I was thinking like, for tangent, what would be radical 2 over 0? So we're going to do 1 over 2, radical 3 over 2, like the reciprocal. The 2 is cancel, so it will be radical 3 over 1. So I was doing that for all of them, but yeah.
Well, look, if you did that, I'll just take off like 5, and that's it. You know.
Because like I swear, like I know, like
Yeah,
I
I
literally
know. It does get
memorized like every
confusing.
single possible thing.
Right.
Thank you.
You're welcome.
Oh yeah. Me too. I don't sleep at all this way. Do you want to hear why? Okay. So, first, I fell asleep at like 12. And then I had a lucid dream. Do you know what those are?
Really realistic.
When you like know you're dreaming and like,
But you're still scared.
you know you're dreaming and you can like make things happen.
Oh,
But
yeah.
then I wanted out of it. I wanted it to be over. And
What was it?
it was Tammy was in it. And we were like all in Campbell's basement and she was talking. And then but then she started talking like weird stuff and then I wanted out of the dream, so I tried like waking myself up. And I was like trying to like heal myself out of dream. Like, you know how you can kind of like wake yourself up? And then I like got stuck and like the dream like wasn't happening anymore and I was like conscious but I like couldn't move. I was just laying there and I couldn't move anything, but I was like thinking like still. I was like, what's going on? And I like kept on trying to move, but it wasn't working. And I felt like I was shaking. I don't know if I was shaking, but I felt like I was moving like this. But then I finally got my leg to move like a couple minutes later.
Yeah, that's a common thing. I've had that happen. It's like anytime you're dreaming, you're in that REM state when you are actually paralyzed, like when you can't. So you're like in between being awake and being asleep. Weird. Did you tell Campbell or not? It was probably you thinking like, you're thinking about her, but then you're like, you don't really want to, and,
Yeah. She started talking about like blackberries. And then I was like, alright, I want to wake up now. But yeah.
Had she ever talked about that before?
No, I don't know. Because at that point I like knew that I was dreaming and I like knew that I could kind of control it and I was just like, I don't know. Yeah.
Interesting.
Yeah. I mean, I was eating blackberries.
Well, she was talking about black bears? I think you said black bears.
Oh, no. Blackberries. How are people doing on the, did you guys have the calculus quiz today?
I had it yesterday. I'm just now grading it.
Are people doing well?
It's my first one. I haven't graded even one yet.
If I can do,
So this is your innovation? I guess you and Diane then have the same one.
Yeah.
Oh, that'd be nice if somehow.
I know. I haven't even seen her yet, but yeah.
Well, she said she settled in her room great.
I know. Me too. And yours is fifth?
Mine's bad.
Did you want it to be fifth?
Sometimes I need to think about things and how it would benefit me. But fifth is always my smallest class. So I thought, well, it should be fifth since I only typically have 14, 15 kids in there.
Gotcha. Yeah. That's nice.
if I can do this while I do well on it.
Mm-hmm.
Did you guys do this worksheet? Or?
Yeah. Do you need to see the answers?
No. No.
I don't even know what my answers are. They're here.
But we did like, you guys did the quick review and the worksheet T1 through T4.
We just did T1 through T4 as our review.
Oh,
What's that one? Let me see that one.
we did that last one.
That's another one. What's this? Do you want to check your answers?
Oh, I already checked the online,
Okay.
I think. It might have been the other one.
You want to do some SATs prep? We have to schedule that for some time, you know,
What?
an SATs prep session.
Yeah, maybe I next week.
Why not just do it now if you don't have homework?
I do have a lot of homework.
Then why don't you get it done right now?
I'm not to get home and do it.
Why not just do it here? When you're at school, you can focus. Okay.
Should I like not really study for that quiz or do you think I should study?
Study a little bit. It's not that hard. I have flashcards if you want to study those. I mean, if you knew how to do that worksheet, it'd be
You
totally
think light
fine.
work though?
If you did the worksheet, if you didn't.
I did the worksheet.
Are you sure you checked it? Because you need to get every single one of them right.
I mean, I feel like I'm probably gonna make some mistakes, like little mistakes. Anyways. Like I only put 2 when there's supposed to be 4 answers. Or I forget to like when I square root it, put the plus or minus above them. I only get 2 instead of 4.
Just look at that.
I just have to remember that. Okay, I think I'm doing this.
So you do definitely want to go to the zoo walk.
You don't want to go.
I want to go, but if you guys are going to back out, then I don't want to pay all the money for it.
Why would I back out?
I just don't believe Zach's going to want to go. I think he's going to end up saying, oh, I mean, it's like his first weekend up there. Or Liam will want to come down or something.
Are you think I'm being really dark?
Maybe we shouldn't. It is going to be hard for me to walk, isn't it?
Yeah. Did you even pass out algebra 2 books?
Mm-mm.
Bye.
I love you.
Bye.
Closed. Thanks.